Okay, so the first part of learning finance is using recurrence relations. So recurrence relations don't have to just be for finance, and indeed when you learned them before, you would have learned them with a variety of different contexts. We're going to mostly be using them with finance context, but to start with, we're going to learn them as more of a general type of maths. So to start with recurrence, we've got our terminology that you need to know. So we've got things like the initial term, which we use the term U0. You can actually use any letter, so it could be V0, which you'll see a lot in finance, but it could be any letter. But it's always a capital letter, really. UN to mean any term, so the nth term, and UN plus 1 we use to be the next term. Similarly, there's actually UN minus 1, which I'm sure you can work out means the previous term as well. So that's also an option. So we use these terms to actually explain patterns and relationships. So for example, if we look at the pattern here, we've got 7, 15, 23. So most of you would be able to work out that that's going up in 8s. So you'd be able to work out that the next number in the sequence is 31. Okay, because we are adding 8 every time. Plus 8. Plus 8. Now that's going up by what we call a common difference of 8. Okay, and that's what makes it what we call an arithmetic sequence. This should all be revision from year 11. So it's going up by a common difference. Going up or down by a common difference, which we often give the letter D, lowercase for. Okay, now if we wanted to write a recurrence relation for this, we have to basically write a rule. That's what a recurrence relation is. It's a rule to describe what the next term is. So in order to find the next term, UN plus 1, that means the next term, you have to use the term that you're on, so UN, and you have to add 8. Okay, so the general formula for a arithmetic sequence is down here. Okay, so UN plus 1 is always going to be equal to UN plus D. Now obviously if D is negative, you'll be taking away a common difference instead. Now if I asked you to find me the 20th term in the sequence, so this is U1, this is U2, this is U3, okay, and I want to get to all the way up to U20. And how would you do that? I want you to just pause the video for a second and see if you can work out what U equals 20 is. So most of you would have worked out that you need to add 8 on a certain number of times. Okay, and if it's 20 times, then you should have worked out that actually you need to add 19 more times, because you're already starting with the first number in the sequence. And so you need to go 19 more steps along. So if we get 7 and we add 8 times 19, that will give us the U20. So if we go to our calculator and we do 7 plus 19 times 8 gets us 159. Okay, now that was using effectively an algebraic rule. Okay, and so a recurrence relation is fine for doing one step at a time, so adding 8 each time. But doing this is actually a lot more efficient when you're forecasting further along a sequence. So to do that, we use what we call a general rule for the nth term. And if the recurrence relation is this, so this is the recurrence relation, then this is what we call the general rule. And it's slightly different because for this we can actually find, that should say u there. Okay, so I'm just going to rewrite that. un equals a plus n minus 1 times d. So let's just pick apart what this means. The first bit there is the first term in the sequence. This here is the common difference. The n, both there and there, is the value of n. So in the example we did above, n was 20. Okay, and so we can use this to find general rules. So if I want to actually create a general rule for the sequence above, okay, I can use this formula to do it. So what I want to do is I want to substitute in all my values. So un is equal to a, which is 7, plus n minus 1 times the common difference of 8. And now I want to expand the brackets. Okay, so I've got un equals 7 plus 8n minus 8. And then finally, I'm going to collect the like terms. So un is equal to 7 minus 8 makes negative 1. So I'm going to write 8n minus 1. And now this formula can be used to work out the nth term anywhere on the sequence. So if I wanted to find out the 30th term, for example, so calculating the 30th term for the sequence above. Have a go now, pause the video and have a go at that one. Okay, so most of you should have done u30 equals 8 times 30, take 1, gives 239. Okay, so rather than doing it all in your head or adding up 8 terms in a row, 30 terms in a row, you can use these rules. Okay, so you need to know the general formula for the nth term, which is highlighted here. You need to find the general rule, which we've done in the step below it. And once you've got the general rule, you can then use the general rule. Okay, so this is the general rule formula. This is finding a rule, and down here is using a rule to find the nth term. Okay, so this is all about sequences and being able to find different terms in the sequence. The next section we're going to do is geometric sequences.